Kevin Culp from Super Micro back at you, continuing our podcast on building an enterprise for virtual machines. Merging technologies such as KVM hypervisor, being able to utilize different technologies of storage presentation for NFS connected across a TCP/IP network or through a sonic switch or storage switch. So we're going to focus this video on compute traffic, talk about different techniques of setting .1Q trunking and so on and so forth for our tagging of our switch. In the previous video, we kind of focused on giving you some insight on how you would create an LACP port channel for a sonic-based switch, how you would go ahead and provision or create or deploy bonded NICs on the storage server, giving you an indication of how you would mount NFS storage across a switch network, and then of course the aspect of mounting that NFS volume across the network. So let's jump into our configuration for the compute traffic and tagging. First thing we need to do is provide a VN list, or basically add VLANs to our switch itself. So we have a number of VLANs already configured here. VLAN 100, 200, and 300 will be tagged packets. And then of course we will also let the native VLAN come across that .1Q trunk on our switch. So let's add in the first VLAN, which is VLAN 100, and we're going to give it a VLAN name of compute VLAN 100, and then we're going to add our secondary VLANs 200, and we're going to give it a name of compute VLAN 200. And the third VLAN 300 with a VLAN name of compute VLAN 300. So we'll hit submit. At that point, we'll push that configuration to our switch, our Arista switch. So these three VLANs are now been configured in the switch. So the next step is to really go to the physical ports and associate those VLANs or assign those VLANs to an uplink port that's connected to our switch. So we'll go ahead and find that uplink port. We have it labeled here, uplink to our corporate L3 switch. That will get out onto the internet and be able to pull down important softwares from the mirrors that exist out on the internet and some other things we want to do for our virtual machines in our custom demo lab. So let's go ahead and choose the Ethernet 11. Right now it is configured for a trunk and allowing VLAN 672. So we want to add in an additional VLANs to that .1Q trunk. So the first thing we're going to do is add in VLAN 1. And that is a native VLAN itself. And we'll mark that as the native VLAN. The next one we're going to do is 100. And that is going to be a tagged particular VLAN. And we're going to add in another VLAN of 200. That is also going to be tagged. And then 300. And that is also going to be tagged. And we're going to submit. So we've now presented those VLANs to our switch. They've been pushed out there. So you can imagine if you're positioning multiple particular VLANs or presenting them to an uplink port, You would have to issue a number of commands in order to do this. You can see here how quickly we can add the VLANs, and we're pretty much ready to hand this over to our server architects, right? So we're the network administrator. We've quickly set these up, and we basically handed the baton over to the server architects to really deploy their VMs and their servers, and then start going ahead and adding applications. So you can see the power of SEC with a couple of clicks, and immediately we have a provisioned particular switch ready to go. So that's how effective it is to provide lifecycle management utilizing SuperCloud Composer. So we've went ahead and added these particular VLANs. The next thing I want to show you is simply the ability to provision the switch itself very quickly, to change them from what we call switch ports to trunk ports through our provisioning wizard itself. So if we wanted to create additional VLANs, we could do so. So we're going to skip that and go to the next step. And you notice here that these are already basically added as what we call access ports. And we already have Ethernet 1, 11, and 45 as trunk ports. So say I wanted to go ahead and basically at this point focus on, say, from 15 beyond to 37. And I wanted to go ahead and move those into what we call a trunk port. You can see very quickly with a stroke of the mouse, immediately we've converted those Ethernet ports directly from access ports to trunk ports. We've reduced the access ports and moved them into the trunk port column. If we click on next here, at this point, we can go in and basically say that, you know, for those particular ports that we were dealing with, which is 15 itself on, we want to basically present essentially at this point a number of ports, right, that we can assign. And then we can continue on through that and then eventually be able to walk through the entire configuration and present multiple VLANs quickly to Ethernet ports, and then immediately confirm the detail and push the configuration to the switch. Very effective way of provisioning a switch. We can do this in bulk with multiple switches. If you utilize our Northbound API to be able to provision through Python and also Ansible as an Ansible playbook. So I'm just going to essentially go ahead and break out of this configuration itself, and then really go back to focus on what we're really doing here from a standpoint. We want to leave the wizard and then go back to the switch itself and get ready to essentially in the next video start focusing on what we call building the KVM hypervisor. So now we've handed off our configuration to the server architects. We've completed our task from a network administrator perspective. We've handed the baton over now for the server architects to continue their work of spinning up applications on their servers. So this concludes our video, very short, giving you an understanding of how you would present and position VLANs to an uplink port to an L3 switch based on VLAN 100, 200, and 300. In the next video, we'll now focus on the server side of things, of how you would prepare your server as a hypervisor by loading appropriate bits, showing you how you configure .1Q trunking, establishing bridges there for your virtual machines to connect to, and then continue on with instantiating VMs, checking for reachability, and doing some initial troubleshooting as well. That concludes this video. Thanks again for joining. We'll see you next time.